Hello, everybody. Welcome to today's webinar with Corero and our SmartWall 1 demo, partnered with Juniper HPE Networking. Unfortunately, our HPE Networking co-presenter was unable to join today, so I'm going to be doing this webinar solo, but feel free to ask questions. I have the question box open, so I should be able to see them if there's any questions during the webinar. Today's demo is focused on really presenting the Corero SmartWall 1 in a live situation, performing DDoS attack detection and mitigation with protection, where we had a the title of it was Power Without Focus is Folly, and the main point of that is orchestrating your network is extremely, with a Corero SmartWall 1 product for DDoS defense, is an extremely powerful solution. But you want to do it in a way that is focused on the type of assets you're protecting, the type of infrastructure that you have, and the importance of those assets as well, because not all assets that are under attack necessarily need to have the same treatment when it comes to DDoS defense. So we're going to be showing you how we can orchestrate the network in that way during this demo. I do have a few slides, but I promise there's not going to be more than 2 slides just to set up the demo. And then we'll go straight into the live demo. So what you're going to see over the next 30 minutes is live DDoS attacks against a lab infrastructure. In this case, obviously, we're not running attacks on the open internet, but you'll see the detection in real time, how the system identifies malicious traffic patterns, our integration, the Corero SmartWall 1 integration, specifically with Juniper routers, but also we'll touch on integration options for other third-party devices as well. And then the full life cycle of having those mitigations not only deployed, orchestrate the network, but then removed so that you're back to a peacetime environment as well. So let me present the next slide. When we look at typical network infrastructures, you have diverse types of DDoS defense, as well as diverse networking connectivity options available. And obviously, you're providing services typically to different types of downstream resources and assets. So you might have a Juniper MX PTX Edge, for example, and you want to leverage that to do edge-based intelligent blocking of DDoS attacks at the edge with integrating with the routers. Or you might have a multi-vendor environment and want to combine industry standard BGP flow spec as well as the Juniper NetConf type of integration that we have. You also might have a more traditional detect and redirect, or also known as a scrubbing solution, where you want, when an attack is detected at attack time, redirect that traffic to intelligent mitigation appliances, whether they be hardware-based or software-based, to do the more detailed, high-grain filtering capability that these appliances bring to the overall DDoS protection problem space. And then based off of what the assets are under attack, you might want to take different actions or use different types of capabilities depending on how big the attack is, what the attack type is, and or how much the person is paying. Obviously, if you're having a revenue generation business around this service offering. So, for instance, residential or eyeball networks, you might want to block at the edge and never redirect them. Commercial customers that are paying a premium price for DDoS defense, you might want to have them in an always-on posture where all their traffic is being redirected to the appliances all the time. You might want to do a combination of those, stop large volumetric attacks at the edge and still redirect traffic all the time for premium customers for more fine-grained or faster detection and mitigation response times, for example. And then you also have the option to have downstream customers potentially even have a physically inline appliance and have that managed as well. So this is a one one configuration or one orchestrator can orchestrate all of these types of capabilities within your network, bringing the best of breed type of DDoS protection depending on what the situation requires. So we'll take that complexity and really simplify it down for lab use cases here. We have an attacker that's going to be running out on the internet, sending attack data. We also have some good guys sending some peacetime data through a router. This is a Juniper VMX in my lab's setup. We have our protected assets and different classes of those. So the residential eyeball networks, the commercial customers like banks, et cetera. And we have, maybe some people that we don't even want to protect potentially as well. Typically, we use sample packet mirror. You've probably heard some of these terms before, or S-flow data. That type of network telemetry gives us visibility into payload data of the samples. So above and beyond what your typical standard NetFlow would provide, that is being sent to a detection device. The system also supports NetFlow, obviously, as well. And when the detector detects an attack, it's going to alert the centralized management system or Corero management system to orchestrate the network based off of the policy of the tenant's assets and service levels associated with those. And that's when you'll see traffic being redirected, et cetera. So we're going to be really focused on the CMS or the Corero management system, as well as the Juniper router during our demo. So let me share my screen now. And my eyes will track upwards a little bit here so you can see this is the Corero management system is on the main screen. We have our detection column. So this would be all the peacetime as well as attack data that's being sampled, whether it be NetFlow or sample packet mirror, sent to our detector. You can see we're in a peacetime status right now. There's no ongoing attacks, for instance. And we have our protection appliances, which is our intelligent DDoS mitigation appliances, and what traffic is going through them. There's certain customers that are always on in this environment, so you'll always have some peacetime data there, but you can see that it's different than what the overall network is seeing. And then we have the streaming telemetry coming back for a feedback loop from the routers over here on the right-hand side, and any remote mitigations. Remote mitigations is the edge. What routers are we orchestrating, and how is the system orchestrating those routers, whether it be based off of DDoS attack rule triggers or overall destination IP or destination subnet threshold-based triggers. So we'll start pretty simple with an attack to a customer, like a residential type of eyeball network where you want to block all attacks at the edge. We'll start that attack really quickly here, but I also will highlight, I'm monitoring our interface counters here. So you can see this is how much traffic is going to our protected victim or assets on this interface. Low traffic levels, about 3,000 packets per second. And this is how much traffic is coming in from the internet or our attacker, for instance. And so you'll see the attacker interface go up, maybe a short spike going to the victim as the attack is detected and blocked. The graphs over here on the left-hand side will be a little bit slower because they're updating automatically at 10-second intervals. So here we go with launching the first attack. Now the system itself is already been, I'll show the policy in a second, but it is already has a policy that's been set up to determine when traffic should be blocked at the edge or redirected. So you can see within a few seconds, you saw the spike in traffic and packets per second here from maybe 2 or 3 seconds. And then the filter was automatically applied. And now you see the victim traffic is back to its normal rate. A little bit later, you're seeing graphs start to be drawn over here on our Corero management system. We know that this is an NTP-Mon reflection attack, for instance, and we're seeing that traffic enter into our network. And we're also seeing router telemetry showing us how much of that traffic is being blocked, for example. So this is all happening automatically based off of getting the network telemetry, in this case, sample packet mirror, analyzing that, understanding that it's an NTP-Mon attack vector, knowing that the policy should be to block that at the edge based off of the destination and the service level that is associated with that destination. And then you can see that this my network is now protected, and more importantly, anything downstream from my edge is protected from that DDoS attack. To show what that filter looks like, because we're using, in this case, instead of BGP flow spec, we're using netconf directly into the ephemeral database of the Juniper fire configuration and placing a specific firewall filter term to block this attack using Juniper flexible payload match capability that is available in the Trio chipset, for example, or the PTX Evo, I think 5. It's also available. So let's do a show ephemeral configuration instance Corero. And you can see this is what the filter was placed that actually created the blocked traffic. So protecting the victim, the IP address that was attacked, the victim IP was identified, what the attack vector was, and specific payload information as well. Now, in this case, we actually are putting in a single term, and it just says count this. So we get the streaming telemetry based off of what's being discarded, and then obviously we're blocking it as well. Now, as I pivot real quick, I'm going to stop that attack. And I want to show you the policy real quick. And it's very flexible that we have from a remote mitigation standpoint. So the system, or Corero, calls this a rule trigger policy. So you have different attack vectors that, for DDoS defense, some of them are known that we have specific payload level detection capability on, and some of them are rate-based unknown type of DDoS attack vectors. These are the active rule triggers, so we can see exactly what was placed when it was placed into service, or when it was orchestrated out to the network, how long that attack has been ongoing. And now that I've stopped the attack, it's showing you that it's going to expire, and then the filter will be automatically removed as well. But the most interesting thing is, how do we build upon, okay, I got you. Okay, no questions so far. How do we build upon this capability starting from, not from scratch, but based off of a multi-vendor environment and all the things I talked about as far as wanting to do different mitigation actions or different orchestration actions based off of device type, router type, as well as the asset importance, as well as the attack vector itself, for instance. So I'm not going to cover all of these options, but it starts with understanding what is the device capability that we're orchestrating. Or if I'm in a multi-vendor environment, I might have Arista or Cisco, for example. If I'm using different types of HPE networking devices, we have specific PTX capabilities that are non-Evo Express 5. That's it, Express 5. And then we have additional templates that leverage the Express 5 chipset, for example, and then another template that leverages the capabilities of a Trio chipset. So we have different mitigation templates based off of the capabilities of that router. And then what we want to do is build upon that based off of what mitigation actions do we want to take, whether we want to use signature-based diversions, signature-based blocks. And when we say signatures, this would be a dynamic in-by tuple match of the DDoS traffic itself, as well. Or if we just want to redirect entire /32s or subnets that are under attack, in case there's a multi-vector type of attack scenario. So we can program what types of actions we want to do, what groups of devices we want to take those actions on, and this all builds on itself so that we can ultimately deliver differentiated services and treat different assets differently based off of the types of attacks they're seeing, the capabilities of our network, et cetera. So for instance, what I'm going to be showing next is we're going to launch a more traditional approach where we're going to do a redirect to a scrubbing center, for instance. So we already launched an attack to an edge protection. So we have a service level edge protect. I attacked one of the IP ranges that is associated with that service level, and therefore all attacks are blocked at the edge, which we just demonstrated. But now we're going to launch an attack to somebody who might be a premium type of customer or is subscribing to a DDoS scrubbing solution from a service provider, and we're going to show that action as well. Let me go back to my home page. Bring this up. We'll take our, let's see here. This is going to be a DNS reflection attack. And you'll know when I launch the attack because you'll start to see the packets per second increase. And see here. So there's our attack is ramping up. And we see some traffic going to our victim. And now the traffic is already being blocked because it's already been redirected to scrub, but we're waiting for the CMS graphs to catch up here. You can see our flow spec redirect has already occurred. We have our rule trigger policy that fired, and now my graphs are starting to catch up. So the detection and redirection with the advertisement of the BGP flow spec route is actually happening faster than our 10-second interval graphs can be updated. So that's why you see a little bit of delay in some of the graphs being drawn. And now we're seeing data not only from our detection perspective, but also from our protection perspective as well. So you can see how much traffic is being dropped. And in this case, the router telemetry doesn't change because the traffic is ingressing that interface, our peering transit interfaces. But once it ingresses, it's being redirected either to a clean VRF or a dirty next hop IP, for example. Now, in case this was one of the benefits of redirecting, actually, let me show the flow spec. This should be, we have some static flow spec routes in here as well, but that's the one that we just added here. So we're advertising a flow spec route that is just matching on the destination IP. Now we could have matched on the signature-based match and only redirected the attack traffic itself if we wanted to, or the source port or destination port, packet length, other criteria, for instance. But in case if it's a multi-vector attack, or the customer or the attacker, I should say, realizes that his attack very quickly is not having the impact that they desired, they might want to launch another attack, for instance. So let me do that real quick. All right, and so now I just launched a new attack vector. And so the traffic is already redirected. We're starting to see this traffic go down, but there was almost no impact to the victim at all. We just look at the block traffic, and now we can see the rules firing. We're a little bit below 10-second update interval. We're a little bit behind, but significantly increase in attack size, different attack vector, different rule. In this case, we're looking at a TCP illegal flag type of attack. So somebody sending probably all flags or Christmas tree, for example. And that's why one of the reasons you might want to not remove those routes, and the system allows you to set those timings. So whether you want to redirect just the attack vector or redirect the entire victim IP address, which is a little bit safer, so that if you do have a multi-vector or a chain vector type of attack, that the victim is under protection by the protection devices all the time. So that was all orchestrated using BGP flow spec. The other thing that we can do is we can start to look at, and this was available before, but we can look at current attacks. We can see each attack has a unique attack ID, how long it's lasting. This information is sent to our analytics system. It can be exported in common syslog format information, as well as sent to our service portal. Don't have enough time to cover all of those options and interfaces today, but those are additional options to view this type of information. But what's really nice is the Corero management system does give you details that in real time of what the attack vector is, how much traffic you're blocking, source port, source ASN, destination information. Since I'm simulating this in a lab, a lot of the information is not super interesting. We are spoofing some countries and some ASNs based off of that, but obviously not as interesting as the real world would be. Let me do a quick check to see if there's any questions so far. All right, no questions yet. So we'll stop this attack vector. And our next attack and workflow that we're going to do is probably, let's say, somebody that they're not paying for a service or paying for protection. So you might want to let a little bit of attack information through, as long as it's not jeopardizing your network, for instance. So I will go ahead and launch that attack now. It's going to be to a different victim IP address. All right, I launched that now. So now we can see the attack is coming through. It's not a super high level attack, 28,000 packets per second, but all of it is going to the victim. And we'll start to see a different type of data being drawn on our screen here. I know it's NTP mon, so we should be able to highlight that. There we go. So we have an NTP mon attack detected. Now we can look at current attacks. Yep, and we're attacking black hole solutions. That's the tenant or the asset that we've defined in our portal, what the type of attack it is. But we're also pushing a firewall filter to the Juniper. If I do my show ephemeral instance, we see it's 60.4, a very specific payload level match. But in this case, we're actually accepting the traffic. We're letting it go through because we're not, this customer potentially isn't paying for us. But we want to make sure that if it gets too big, we want to RTBH it, for example, or remote trigger black hole route it. You can see the different telemetry source here. Now we're showing this as detected traffic instead of mitigated traffic compared to our block traffic or allowed. Then we can graph all three back again. So let's say that attack, though, ramps up, and we want to make sure that if it gets too high, we want to block that traffic. So we'll increase the threshold here to about 100,000 packets per second. We're at 100,000 packets per second. Now you can see that it's making it to the victim because we're not blocking that traffic, but now we just fired a remote trigger black hole. And this is all happening automatically in seconds based off of the configured policy. And in this case, I have a specific policy that is saying for non-subscribed customers, go ahead and RTBH them. And because my lab, I have thresholds that I can't generate too much traffic levels. I have it set pretty low, but in the real environment, this would be set probably at a gig or 10 gig, for example, or for some networks even higher, depending on what level of protection they want to provide assets that aren't paying for protection as a service. If I show that route here real quick, let's see if I can find it. There's our route that was automatically advertised. This time, instead of using BGP flow spec, we just used normal BGP, and we could have tagged that with additional communities that would have black holed this upstream. In this case, I'm only discarding it locally on the network. As you can see with our graph, we see the increase of detected traffic. The firewall filter is still matching that traffic, but it's never leaving the router. As you can see, the traffic to our victim has completely dropped off. So that's another workflow. And we have about 3 minutes. So I will try to squeeze in one more type of attack. So you can see maybe a carpet bomb attack and going to an always on customer, for instance, somebody who's always being protected. And you can see right here, I just launched the attack and there was basically no impact to the victim at all. The packets per second increased from our attacker, but to our victim, it never really even saw an increase, or maybe just a few packets. But the other thing you're going to notice here with these types of attacks is the additional capabilities that a protection appliance provides. This is a SYN flood attack where you need to do anti-spoofing challenges. You can't just block all SYNs to port 443, for example. So in this case, we're doing multiple rules are firing. We have our anti-spoofing checks. And then eventually the system, if I highlight this one, the system itself has already determined that these sources are not legitimate. They're not legitimate connections. And rather than continuing to fire different, more stateful type of rules, not fully stateful, they're more semi-state to track whether the client is legitimate or not, the system automatically determined to start blocking the sources themselves. Again, you can drill into current attacks, and we can see that SYN flood is a carpet bomb attack, and it actually is hitting two subnets that are differently. So two different /28s, because that's how we have the assets defined, and it can track /24s as well. And we're running up on time, almost complete for the webinar. So I wanted to thank everybody for joining, hopefully seeing the system in real time, showing how fast it is and how you can leverage it to protect your network and offer different levels of services depending on the assets you're protecting was beneficial today. So thanks again, everybody.